And now, Ernie, if you will, roll that beautiful bean footage of that first one there. And what we've got going on here is this is the CNC, basically, that we just acquired. We've had it for 3 months?
Yeah, at the
Maybe.
most.
We had some smaller ones. This is the first full sheet one that we've got. And of course, there's people chomping at the bit wanting to use this for all sorts of things. And the reason I brought up, you know, the different steps between EV, DV, PV, and MP, you know, if we have to go back and forth on getting something right, let's say it's the durometer of the surround, the material in the surround, the number of ribs in the surround, the spacing, anything like that, this machine now gives us the capability to make, we always call them soft tools.
Yep.
And with a soft tool, you can, to do something like this probably takes about a day to mill out. And then I've seen you pull parts. You can pull parts in 30 minutes.
Real quick, yeah.
Real quick.
Real
once
quick.
the machine's warm,
if the machine's warm, we clamp the material in there, and if it's Sanaprene, I mean, it's instantaneous. As soon as we put the vacuum on it, it's
sucked down your gun.
Yeah.
So this is a tool, this big CNC that we've got, and we captured some footage of it here in action. I want you guys to see this. Is we can use this for doing a lot of stuff in-house. Our guys like Tim and the guys in the back who do special operations and projects and demo vehicles, they can use this. They can lay out a box, they can do logos, they can do whatever they want on this big machine. But we also, the other focus on this is we can use it to make soft tools directly off of our engineering work up front. So they can take what they're working on in engineering, we can run it to the back and put it into this CNC, and we can create soft tools in a day sounds like a long time, but there's a lot of detail in a surround. There's a lot of things that have to happen to get that carved out, but a day of carving time is a whole lot quicker than requesting new tool, overseas, shipment, getting it back. So we could probably, this right here takes us a day. It essentially could easily shave 3 to 4 weeks off a development process.
This one actually took just under 6 hours.
To do this one.
To do this one. And we actually have the piece right here. We can show you guys in better detail. But yeah, you can set it at a higher resolution, and it predicted that would take 12 hours. But for the Sanaprene sample, we didn't need higher resolution. So we might as well go ahead and get it done. And in the same day, we were able to build the tool, put it on the machine, and get ourselves a surround.
So that machine, so we'll give you, I know Tim was over on camera 3 getting it lined up, or camera 1, I always get them mixed up. He's got a view here. So actually, zoom in, Ernie, if you can. Let's move to, that's enough on the CNC. I can only watch it cutting for so long. But this is the actual tool that came from that video that we shot.
Yep.
And Aaron let me know, because, I mean, Aaron is always looking, he's saying, hey, we're getting ready to do this today. Do you want to capture some footage to put on the show? And because of that, that's what led to us actually saying, Aaron, let's just get you on the show and talk about all this. I think people find this interesting. So this is the actual tool that came out of that CNC machine, which started with our engineers up front. And then this part was taken right out of the CNC. Aaron took it over to the vac form.
Yep.
And you pulled, well, pull on
that. Actually, this is the material. This is some raw material. We get this in various thicknesses in durometers. Durometer is the hardness or stiffness of the material. So we'll start here. We'll cut a piece. I usually cut a 25 by 25 piece, throw it in the machine, and put the vacuum, get it hot, of course, and put the vacuum on it. And then we end up with a finished product that our techs can then glue to an actual woofer for testing. So if I can get this loose here. Here's an actual finished surround.
That's
so that's what
hold
we
it up
get.
There for Timmy. He'll get it on the cam. But that is an actual surround that you pulled off of the tool.
Yes.
Off of the vac former, right here in house. So something that would take weeks for us to do typically, you did in a day.
Yeah, and you know, it's nice because, like I said, we can then get this to our techs. They can glue it on a driver, and then we can do immediate testing. And if it doesn't work, guess what? I can go back to the machine, I can get thicker or a thinner material or whatever adjustment we feel like we need to make, throw it on the machine, and we have another one. And we don't have all that lead time and downtime with requesting a sample from the vendor. So it's really cool that we have the ability to do this. It helps to speed things up drastically. And
I saw Ernie, which thank you, Ernie, for starting that. This is actually the video I shot of you at the vac former, and you're actually pulling the part here. And as you can see, that's the tool loaded in. There is the material, hopefully, well, it's in the video, you'll get to it, but you actually slide by the way, this thing makes a great pizza warmer, by the way.
Yeah, we bake cookies in it and everything else.
But, you know, the material, as you can see, it's clamped in with these air-driven clamps that holds the material, and then you literally just slide it in, you cook it, get it warm, and then when you pull it out, it'll be vac formed. Now, a question I asked you, how do you know when it's ready to pull?
Okay, well, that was something that we kind of had to figure out when we first started. You can read ExxonMobil's website, and I believe that the forming temperature for this material, because it is an ExxonMobil material, I believe it's 385 degrees. So I was trying with a temperature gun and trying to get it heated to 385 degrees, and it wasn't working out. And we finally got it working. And then after doing it over some years, I finally learned that all we really need to do is look at the material. So when it starts getting hot, first the material will sag, then it'll wrinkle. There you guys can see the vacuum form process there. But
I mean, it's just like that. It's
yeah,
just
it's
instant.
instantaneous. ABS, of course, especially thicker, it's going to take a little longer to pull it into the form. And we also do some ABS enclosures and things of that nature on this as well.
Marcus Nance has got a question up on the screen. Thank you, Sandy, for that. Is there a limit on the size of the material it cuts? So I'm sure Marcus must be referring to the CNC.
The CNC, it's a 4x8.
So it's 4x8
sheet of wood.
So as far as size, we can go 4 foot by 8 foot.
Yes.
And as far as thickness, it's adjustable, isn't it? I mean, we can.
Yeah, I mean, it's pretty tall. I mean, you could do a pretty tall.
Right.
You could cut out a pretty tall piece.
Yeah, I don't have the exact number. We could check on that and obviously bring it back on a future show, because what I'd like to do, guys, is and if you enjoy stuff like this, let me know, because I really want to get Aaron on the show at least every 45 to 60 days and talk about stuff like this, because Aaron is in R&D and he's got his ear, he's got his hands on this stuff all the time. And I think it's really cool to have Aaron give us updates and show us what they're doing. And I felt this was a really good first step to kind of show the tools that we can manufacture here that you use on a daily basis to make our products.
Yeah.
Develop them. I mean, once they're done and signed off on, obviously all this turns into real aluminum tools and things like that. But we have to start with prototyping to know where we're going.
Exactly.
So you've brought, before I skip to the other videos, Ernie, hold off on the other videos for a second, but before we get to those, what other tools have you brought here and what do they represent?
Okay, so this, for example, this is a 3D printed tool that we have the ability to do in our R&D department. And so our mechanical guys 3D printed this. What this is a sealing spider for a marine product. So this actually glues to the cone and then also attaches to the post of a coax. So it seals the gap there and water can't get in. So for our marine products, we like to use these sealing spiders. So there's an example. Here's another example of a sealing spider that we did with just a half roll.
And speaking of those, what's cool about that is I remember the design team, which is another meeting we have where marketing and sales and R&D gets together. And I remember the meeting where we looked at the canned product and we looked at that's an intrusion point that we probably should take care of, and that created the conversation, which led to let's create a sealing spider to go there on that outside to prevent water, salt, or whatever getting down into there. And so that conversation from the design team evaluating where we were at on that product, which at that point I don't know if we were in the EV or DV process, but that's what prompted us to do this. And what was cool is you could go print this, go pull it, and we could put it on a product and try it almost instantly.
Yeah, it's nice. Our mechanical guys draw it up, they send it to the 3D printer, they give it to me, and we have a part.
Now, something that's interesting, and this is why I have it, Aaron actually gave it to me, I could keep it here on the show, but underneath that stack, that is actually, the surround we kept talking about, that is actually a tool that you had made from the 3D printer.
Yes.
And the one thing that we found out over time, and one of the issues with a 3D printed tool, is that heat tends to deform them. You can only get so many pulls off the part before it's no good.
Yes, I mean, the material that we're pulling here is called PLA. So it's not going, or that we're printing here is called PLA. So it doesn't handle a lot of heat. It's a fairly basic 3D printer for us to just, be able to see some concepts. That's why it's nice to have this CNC now, because these can't really stand up to the heat. They warp. And
well, that one there, did you get a close-up on that one, Timmy, the part
I probably
there?
set it down too fast.
Show, kind of point out, you can see, I mean, obviously we're here in studio, you can see, but you can tell where this part, after pulling a couple of the surrounds off of it, it started to warp and do things.
Mostly at the foot, you can see, right in here, it's warped pretty bad. But then it's deformed and the surround doesn't act like it needs to act, and so it's kind of worthless for us.
So that's why he gave it to me, so, give a worthless tool to a worthless guy and we go get along great in the studio. But I really think, we get exposed to this stuff on a daily basis, and of course I see it because I come down and interface with you guys, but I felt it was worth bringing all this to the table and talking about this, because it is how we can and do develop products. And here in the last couple of months, we've even added more tools to our stable so we can do this type of prototyping much faster.
Definitely.
So what's this?
This is a dust cap.
Oh.
So we needed a dust cap for a driver. So As you can see, it's kind of, I don't know if you can see that. I'll try to turn it so you can get some shadows going there. But yeah, that's just a button-shaped dust cap.
He'll get a close-up on it. Look at Tim there. He'll get it.
I can't remember which product this was for. It's probably for a product we don't have available yet. But there you go. You can see all the holes for the vacuum. That's what allows the material to pull in. And for this, we actually used polypropylene. We didn't do a Santoprene dust cap. And so we've also got polypropylene. We've got sheets of this stuff, plastic basically, thermoformable plastic in various thicknesses. So we could do cones, we could do dust caps, whatever we need to do.